Questions 5 through 7 on the 2005 Grade 12 Euclid Math Contest. A goat starts at the origin 0, 0 and then makes several moves. On move 1, it travels 1 unit up to 0, 1. On move 2, it travels 2 units right to 2, 1. On move 3, it travels 3 units down to 2, negative 2. On move 4, it travels 4 units to negative 2, negative 2. It continues in this fashion so that on move n, it turns 90 degrees in a clockwise direction from its previous heading and travels n units in this new direction. After n moves, the goat has traveled a total of 55 units. Determine the coordinates of its position at this time. So let's first plot all the things they tell us in the question. The goat starts at the origin, which is obviously there, 0, 0. And then it goes 1 unit, travels up. Okay? So it's going to go up to here, approximately. And then, so this is what? 0, 1. And then it makes a turn and goes right 2 units. 2, 2, 1. So 2, 1 is approximately here. And then it turns again and goes down 3 units to negative 2, negative 2. So to here. 2, negative 2. And then it moves 4 units to, I guess, the left to get to negative 2, 2, which is approximately here. Okay? So you kind of get the idea, right? It's going to turn every time, and each move is one more than the other. So this was 1, this was a move of 2, this was a move of 3, this was a move of 4, and so on. All right? So that's the initial setup of the question. Now they're telling you that after n moves, so we don't know what n is, it's traveled 55 units. Well, you can clearly see in this diagram that after each move, it's going up by 1, right? 1, then 2, then 3, then 4. So 1, then 2, then 3, then 4, and so on, all the way up until n. That's basically how you would add up the distance that this goat travels. And they're telling you that that is 55. Okay? Now, the sum of this, we know, is that formula n times n plus 1 over 2, and that is 55. And if you multiply this, you get n times n plus 1 is equal to 110. And you can use a quadratic, or you can just do this by inspection. By inspection, I can clearly see that n is equal to 10, because 10 times 11 is 110. All right, so 10 moves. So I've got to continue in this fashion 10 times. All right, I think I can do that. Let's see here. I've done it 4 times already, so I've got to do 5, 6, 7, all the way up to 10. All right, so let's do the 5th one. How many moves? I'm going up 5, right? Because it's the 5th move. So 5 will be till approximately here. So let's do this carefully so we don't make any mistakes. So I'm going up by 5 on the 5th move. So this point, therefore, the x coordinate will stay the same, but the y coordinate, I've gone up by 5, so negative 2 up by 5, it'll be 3. Okay? So as long as you don't make any mistakes, you should be okay with this question. Now we're going this way, but this time we're moving across 6 units, correct? So 6 units would take me probably till about here, okay? So that was 6 units. Now what's my coordinate right there? Well, let's see here. The y coordinate stays the same, but I moved in the x direction, so I've moved 6 units from negative 2, so that would be 4. That's my coordinate. All right, we've got 4 more moves. I'm going to move down now. 7 units. So approximately here. It doesn't matter. It's not like it has to be drawn to scale. You get the point. 7 units. Now, the x-coordinate stays the same, but I moved in the y direction 7 down, so this will be -4. Okay? Hope you're following. No problem. Now I've got to go in the other direction, this time 8 units. So I'm going to end up somewhere around here. Now let's figure out the coordinates. I moved in the x direction, so the y coordinate stays the same, but I moved 8 units in the x direction. So 4 minus 8, and that puts me at -4. All right, got 2 more. And this time I'm going up by 9. So 9 would be somewhere here, approximately. All right, so that was a move of 9. I moved in the y direction, so my x-coordinate stays the same, but I moved up 9, so -4 plus 9 is 5. And the final move, 10. 10 and going right. Oh, so let's see here. 10 going right would be approximately here, right? So what's that coordinate? That's going to be our answer. I moved 10 going right. My y-coordinate stays the same. And my x-coordinate, I've added 10. So -4 plus 10 is 6. And there you go. That is the point you need to be at for this question. And what were they asking? That's it. Just determine the coordinates of the position at this time. So the coordinates are 6, 5. Determine all possible values of r such that there is a 3-term geometric sequence 4, 4r, 4r squared that is also an arithmetic sequence. 4, 4r, and 4r squared are our terms. And this is obviously a geometric sequence, as they mention in the question, but they're saying that it's also a arithmetic sequence. An arithmetic sequence are of the form a plus d, a plus 2d, a plus 3d, and so on. Now, if it is indeed a arithmetic sequence like that, that means that if you take the second term and subtract from it the first term, it will be equal to taking the third term and subtracting from it the second term. Right? Because watch what happens. This becomes just d on that side and on the left side. On the right side, it becomes just d. So that's obviously true. D does indeed equal d. So now we need to do that with those numbers right there. So I'll take the second term, subtract from it the first term, which is 4. And in the same way, I'll take the third term and subtract from it the second term, which is 4r. And this will help us solve for r. Divide everything by 4. I think that's a good step. So that would just leave me with r minus 1, r squared minus r. And then put everything on one side. R squared minus 2r plus 1 is equal to 0. And I think this factors, let's see here, r, 1, 1, negative, negative. Yeah. So therefore, r is equal to 1. And that's it. That's the only value. So they say determine all possible values of r. Well, there's only one value, and that's r equal to 1. Equilateral triangle ABC has side lengths 3 with vertices B and C on a circle of radius 3. As shown, the triangle is then rotated clockwise inside the circle, first about C until A reaches the circle, and then about A until B reaches the circle, and so on. Eventually, the triangle returns to its original position and stops. What is the total distance traveled by the point B? So the first thing, of course, is we've got to figure out what's going on. We've got to understand this question here. So I'll try to explain it in a way that makes sense, hopefully. So here we go. Originally, of course, we've got A, B, and C, right, like this. So here's A, and here's B, and here's C. And the very first move that they make in this question is that you're going to rotate first about C, right there, okay? Very important that we understand the question. First about C until A reaches the circle, okay? So let's draw that. And there you go, that's the first one. So C stays here, but A touches the circle. And then B gets placed in the middle, just as A was here. Okay, so that's the first move. Now, before I continue, let's talk about B. B was approximately here before, right? Just put that in brackets. It went from here to here. But how did it get there? Did it go in a straight line like that? No. It went, and let's see if I can illustrate that. Originally, B was here, right? And it moves like that. Now, the entire time it moves, this distance from B to C stays constant. Correct? Because eventually it will get right to there. So that means when it does move like that, it's going to move in a curve. So something like this. All right? Where that entire time the distance from C to B remains the same. Basically, it's part of the circumference of a circle, where the radius is this length from C to B. All right? So now let's continue with this question. Let's go to the next move. Now, they tell you what the next move is, then about A until B reaches the circle. Okay, let's draw that. So approximately something like that, where this is B, and this is A, and this is C. All right? So in a very similar way, when B was here, and then it moves to here, how does it actually get there? Well, again, it travels in the exact same kind of pattern that it would be a curve. All right? And that curve is basically like this. Kind of like that. Okay? So we got to keep going here, and I'll draw in the other ones. We're going to keep going until we get back to the original position, which is over here. So I'll draw all those in. So there you go. Those are all the moves. So let's talk about B. B was originally here, correct? And eventually, in the first move, it ends up here. And I drew the curve that it follows. And then in the second move, it ends up here, and I drew the curve that it follows. In the third move, it stays here. Notice that. So here there's no movement of B. And then the next one, it goes here. So it was here, correct? Put a little B in brackets, and it went here. And remember, it goes around like a curve when it moves. Its path is the shape of a curve, the part of a circumference of a circle. And then the next move, it goes here. So again, it's traveling in a curve to get from its center position to there. And then finally, this is the original position, and you notice at that point there's no move that it had to make to get there. It just stays there. So our total distance that B travels, which is what they want you to figure out, would be this distance, this distance, this distance, and this distance. Those four. And the good news is that all four of those are equal. All right? So I'll just call that D for distance. Okay? Now we got to figure out what is the value for D. If I can figure out 4D, that will be the answer to the question. Correct? All right? So how do I figure out D? What's the story here? This is how each of those D's is calculated. D is basically this path right here. You see how it's a circular type of path? That red line is D, essentially representing this right here. And the good news is that we know the length from here to here. That is essentially the length of the equilateral triangle, and that's 3. And this is 3, and that's 3. Now, since it's equilateral, this is 60 degrees. So we can now figure out the distance from there to there. That represents D. How? Well, this angle is at the heart of that. 60 over the total way around, 360. That is the fraction of the circumference of the circle. That is equal to D. All right? So that becomes 1/6 of C is equal to RD. And 1/6 of circumference is basically equal to pi times 2r, where r is the radius. And the radius, of course, of this particular circle in this diagram is 3. So that gives you pi times 2 times 3 all over 6. And this looks like D is just equal to pi. So our 4D will be 4 times pi. And there you go. That's the answer to the question. So what is the total distance traveled by point B? The answer to that is 4 pi. In the diagram, ABCD is a quadrilateral in which angle A plus angle C is 180 degrees. What is the length of CD? So I will call this X, angle A, and therefore this will be 180 minus X, angle C. And this immediately screams law of cosines. And if you're not familiar with law of cosines, I'll just give you a very quick primer. Let's say you have a triangle, and you label that triangle A, B, C, and these sides have length A, C, and B respectively, and this is angle theta. Law of cosine states that A squared, this little guy, is equal to B squared, this length, plus C squared, which is here, minus 2BC, and then the cosine of that angle A, which in our case I have labeled as theta. All right, so that's the law of cosines. So we're going to use that in this diagram right here. First, we will use it on this triangle right here, ABD. So we've got 7 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 cos of x. Correct? So that gives me 49 is equal to 25 plus 36 minus 60 cos x. And then bring the 60 cos x on one side. 25 plus 36 minus 49 is 12. And therefore the cos of x is equal to 12 over 60. And you get out your calculator, you'll get x is equal to approximately 78.46 degrees. And therefore 180 minus x, which is the value of this angle right here, is going to be approximately 101.54 degrees. All right? So now what do they want us to figure out? The length of CD, this guy right here. I'll just call that y. And again, we will use the law of cosines, but this time on this triangle, BCD. So here we go. I think I can put that in there. So we've got, let's see here, 7 squared is equal to y squared plus 4 squared minus 2 times y times 4 cos of C, this angle. And that would be 49 is equal to y squared plus 16 minus 8y, the cos of that angle was 101.54, 101.54 approximately. And this gives me, let's see here, y squared minus 8y. And then this is negative 0.2. And then anything else? Oh yeah, the 16 minus the 49, so that's minus 33 equals 0. So this simplifies to y squared plus 1.6y minus 33. Okay? So I guess at this point we have to use our dreaded quadratic formula, and shouldn't be too bad. So minus b plus or minus the square root of b squared minus 4ac, like that, all over 2a. And that becomes minus 1.6 plus or minus, if you do the math there, you get 2.56 plus 132 all over 2. And this becomes negative 1.6 plus or minus 11.6 all over 2. And this gives you either minus 6.6 or 5. Now obviously y is a distance, so it can't be negative. So it will be 5. And y I chose to represent DC, or CD, and that is what they wanted. So there you go. That length is 5. If f at x is equal to sine x squared minus 2 sine x plus 2, what are the minimum and maximum values of f at x? So there's several different approaches to this. I'm just going to use the very basic approach, which is just making a table. Why make it more complicated than it needs to be? So f at x is sine x squared minus 2 sine x plus 2, right? And I'll just use a few points and then we can figure out the max and min. So in this column, I'll put the value of f at x. And in this column, we will put sine x. And then in this column, x. So my x values, I'm just going to use sort of 45-degree intervals. So 0, 45 degrees, 90 degrees, and so on. 135, 180, 215, 225, then 270, 315, and finally 360. These are all degrees. And then for sine x, I can easily figure that out. You're allowed to use calculators on the Canadian exams. So this is going to be for sine x 0, root 2 over 2, 1, root 2 over 2. For 180, it will be 0. 225, it will be a negative root 2 over 2. 270, it's negative 1. A negative root 2 over 2. And then finally back down to 0 again. All right, now let's figure out our f at x. So here we go. If x is 0, f at x would be 0 minus 2 times 0 plus 2. Correct? So there you go. That's the first one. If x is 45 degrees, then sine x is root 2 over 2. So this is for x equal to 0. If x is equal to 45 degrees, we're going to get root 2 over 2 all squared minus 2 times root 2 over 2 plus 2. And that looks like it will give you, let's see here, 2 over 4 minus root 2 plus 2. And that looks like 5 over 2 minus root 2. And in terms of a decimal, it just makes it easier for me to compare. About 1.08. 1.08 goes in there. All right, so you get the hang of this, right? So let's keep going here. F at x, when now we have x equal to 90 degrees. So that's 1. So it would be 1 squared minus 2 times 1 plus 2, like that. So this looks like 3 minus 2, which is 1. So this is 1. Root 2 over 2 we just did up here, so that's the same as 1.08. And 0 we did, so that's 2. All right, saves us a little bit of time when some of those are the same. Now let's go with 225 degrees. That's going to be slightly different. So for 225, we've got minus root 2 over 2 all squared, minus 2 times root 2 over 2 minus, and then plus 2. So this looks like 2 over 4 plus root 2 plus 2. So this is 5 over 2 plus root 2, which is approximately 3.91. So put 3.91 in there. And then 270, I think I can squeeze that in here. When x is 270. So it's negative 1, right? So negative 1 squared minus 2 times negative 1 plus 2. That looks like 1 plus 2 plus 2, which is 5. So that goes there. This one we already did. And this one we already did twice, actually. So there you go. A cool little table. And we want the max and min value of f at x. So it looks like the maximum is 5. And the minimum is 1. So there you go. This is the minimum. And this 5 is the max. So that answers 7 part A. In the diagram, the parabola y is equal to negative 1/4 x minus r times x minus s intersects the x and y axes at 3 points. The vertex of this parabola is at point V. Determine the value of k and the coordinates of V. In any parabola, it is usually of the form y equals ax squared plus bx plus c. It can also be of the form y is equal to a times x minus h all squared plus k. And if it's in this form, then the vertex is conveniently figured out as hk. This is h, that's k. So we've got it in this form, which is obviously not in either of these forms. That's no problem. We can probably figure out a way of doing this. So the first thing, of course, is they tell you that you've got roots, meaning when you set y equal to 0, you're going to get values of x here and here, correct? So that means we will take our equation that they give us and see what the roots are. So we got 1/4 x minus r times x minus s. Set y equal to 0, like that. And this, of course, will be 0 when x is equal to either r or s. Now, they already told you in the graph that we've got roots in the form of k. So if I let r greater than s, because I've got to choose one or the other, that means I can let my r equal 3k, this guy right here, and I can let my s equal to negative k, which is right here. And then going back into the formula, I can substitute those values in. So instead of dealing with r's and s's, I can just use k's. So that means it becomes y equals negative 1/4 x minus r, which is 3k, and then x minus s, which is minus k, so that would become x plus k. And we can therefore solve this knowing that we've got one specific point on there where the x coordinate is 0. That's going to help us to solve for k. So y in that point is 3k. The x coordinate at that point was 0. So substitute that into this formula. and that will help us solve for k. That will be answering half the question. So let's see here, 3k is equal to negative quarter minus 3k times k, so that's minus 3k squared, like that. Okay, let's move this up a bit. All right, where do we want to go from here? Let's just put everything on one side. So we get 3 over 4k squared minus 3k is equal to 0. Multiply through by 4, and you get 0 is equal to 3k squared minus 12k. Factor out a k, and you'll get 3k minus 12. And therefore, k is equal to 0, or k is equal to 4. Now, obviously, k can't be 0, because if k is 0, then this would make no sense. So k is therefore equal to 4. So there we go. We've got the value for k. Now they want you to figure out the vertex, the coordinates of v, which is the vertex of that parabola. And to do that, we've got to get this parabola in this form here. And I think that should be possible. Let's see here. K we just figured out was 4, right? Yeah. So if k is 4, that means r is equal to 12 and s is equal to negative 4. So using this original formula, that would give me y is equal to negative 1/4 x minus r, which is 12, and x minus s, which is negative 4, so that would become plus 4. All right, let's move this up here. And then this, we have to get this into this type of form, ax minus h squared plus k. And then when we do, our vertex v will be hk. Okay, I think I can do that. It's called completing the square. I'm sure you've done that in your math classes. Completing the square. All right, so here we go. Let's complete the square with that one. So y is equal to negative 1/4. Let's multiply that out. So it'll be x squared plus 4x minus 12x minus 48. This becomes minus 1/4, x squared minus 8x minus 48. And here's where we complete the square. You've got to take half of this, which is negative 4, and then you've got to square that. So negative 4 squared is positive 16. And then you've got to account for the fact that you got a minus 48. How do I get minus 48? Well, I'd have to subtract 64. And if you've done enough of those, then that should be pretty straightforward. So then this becomes minus 1/4, x squared minus 8x plus 16. We only want to keep this in the brackets. We want to kick this guy out. But before you kick it out, you've got to multiply by that. Don't forget that. So negative 1/4 times negative 64 gives you positive 16. And then the brackets in here will factor to x minus 4, all squared, and this is plus 16. So there you go. You've got it in this form. And if you've got it in this form, my vertex is therefore 4, 16. And that they have called V. So there you go. That is the answer for 7B.